Hi friends, in this video we see control system questions from Tripoli branch asked in TRB 2018 exam. The first question is the polar plot of the system shown in figure. What is the type of the system? Right, we know that the polar plot has the general form like this. Right, it will always start from the type. So this is talking about type 0, this is talking about type 1 of the system, this is talking about type 2. Sorry, this is type 2, type 3 of the system. These are all starting point of the polar plot. Whereas endpoint is determined by order. So this is endpoint. If it is in here, it is first order system. This is second order system. This is third order system. This is fourth order system. Our diagram starts from here and ends at here. So it starts from here means it is type 0, and where it ends here. So it is type order 2. So our system is type 0 order 2. What they ask is type 0 system type only they asked. So the answer is option B, type 0. Next, the mass element can be expressed as, we know that mass can be expressed as F is equal to md squared x by dt squared, direct question. So option B is the right answer. Next, okay, if a step function is applied to the input of a system and the output remains below a certain level for all the time, the system is. So the input is step input. So the step input, the amplitude is always bounded. So we apply bounded input. Right? Okay. Then what happens? The output remains below a certain level. That means output is also bounded. So bounded input produces bounded output. That means it is always stable system. Suppose if the condition is not, if this condition is not given, that is output remains below, then it will be not necessarily stable. So for this question, the option B is correct answer. I don't know what is the answer in TRB, but the exact answer is option B, right? Okay. Next, the type 2 system has dash at the origin. How many poles? We know that number of poles at the origin is determined by type of the system. If it is type 0, no poles at the origin. Type 1 means 1 poles. Type 2 means 2 poles are lying at the origin. So option D is the right answer. Next one, the unit impulse response of a second order underdamped system starting from the rest is given by C of t is equal to 12.5 in t power minus 60 sin 80. The steady state value of step response of the system. So what they have given? They have given unit impulse response of the system, right? So unit impulse response of the system they have given. They ask step response of the steady state value of the step response. So we know that once impulse response is given, step response is obtained by, right, differentiating, integration of this one. But if you do all the things here, it will be very complicated things. Instead, what I am going to do is I am going to work with the S domain. How? See, they have given C of t, impulse response. If I take a Laplace transform, it will become C of S, right? We know that C of S by R of S, right? So this is impulse response. Let us take the typical notation of H of t, right? So this is H of t. In the problem they have given C of t, we take any of. So my input I assume as C, my output I assume as R. So C of S by R of S equal to impulse response, because output by input is impulse response, so it will be H of S. Yes or no? Because what is impulse response? That is output by input, right? Because C of S, that is output is equal to input into impulse response. That's what we know in Laplace domain, right? So this implies C of S equal to H of S into R of S. This we know. Or simply C of t is equal to H of t star R of t. That we know, right? Output is a convolution of input and the impulse response. The same concept I am using. So they have given impulse response. They know that they have given what they ask, what is the steady state value of the step response. What is step response? Step response is nothing but the response obtained when unit step is given as the input. So what is my input signal R of t? R of t is equal to u of t. What is my R of s? That is equal to 1 by s. What I have to find? C of t, that is impulse response when R of t is given at t tends to infinity, because they are steady state. Clear? So I know I can find C of s. From C of s I find C of t. So what is that? C of s is equal to R of s into H of s. R of s is given by 1 by s into H of s. H of s is nothing but our impulse response. What is the impulse response? That is equal to 12.5 into e power minus 60 sin 8t. Right? So h of t is equal to 12.5 into e power minus 60 sin 8t. I find h of s. H of s equal to 12.5. E power minus 60 Laplace transform sin means it is 8 divided by s square plus 8 square. But here it is shifted by e power 6, e power minus 6. So I have to put s plus 6 whole square. Now h of s I found. So what is my C of s? C of s equal to R of s, that is nothing but 1 by s. H of s equal to 12.5 into 8 divided by s plus 6 whole square plus 8 square. Now what I need? C of t, and t tends to infinity. But if I find it is C of t means it will be a tedious process. Instead I use final value theorem. What is that? Limit t tends to infinity C of t. This is what I want now, because C of t infinity only I want. That is equal to limit s tends to 0 s into C of s. This is simple, right? So I use right hand side. So what is that? Limit s tends to 0 s into C of s is nothing but 1 by s, right, into 12.5 into 8, 100. Okay, in 100 divided by s plus 6 whole square plus 8 square. S tends to 0, so this is cancelled, this is 0. So 100 divided by 100, that is equal to 1. So the answer is option D, 1. Okay, next question is find the signal from the signal flow graph shown in figure, find the value of C by R. Right, we know that how to find. We have to use Mason's gain formula, that is given by T is equal to 1 by del summation K Pk del K, where T is a transfer function, Pk is gain of forward path, del is equal to 1 minus sum of individual loop gain plus sum of gain product of all possible combination of two non-touching loops, like that it will go. Then what you have to find? So first we find a forward path. So forward path means it has to start from the input and ends at the output without returning. So let us go from here, it is going. Okay, right. So if you multiply all the gains, then it will be known as forward path gain. Here gain is A, here gain is B, here gain is C, here gain is D. So first forward path has gain of A, B, C, D. Do you have any other gain? No, because no forward path. This is the only one forward path exists. So gain, the first forward path gain, we are having first forward path, that is A, B, C, D. We don't have any other gain. So number of forward path is K, that is equal to 1. First forward path gain is A, B, C, D. Now we write what are all the individual loop. Why we are finding the individual loop? Because del is equal to sum of individual 1 minus sum of individual loop gain. So we have 3 individual loops. You see, loop is the one we start and end at the same point and go in the same direction. You see here, this one is starting and going, okay, ending at the same direction. This is one loop. Here also it is starting and ending at the same direction. It is another loop. It is another loop. So we have 3 loops. It is 3 individual loops. Okay. So the gain product of, so first, what is the gain product of first loop? Let me draw. First loop is like this. Right? It has been like this. This is B. This is minus F. So what is the gain? Minus BF. What about second loop? It was like this. Right? It's going and coming. This is C, this is E. So the gain product is CE. What about third loop? It is going like this. G. So the gain product is simply G. So what is the del value? Okay. Del is equal to 1 minus sum of individual loop gain plus sum of gain product of all possible combination of 2 non-touching loops. Let us see whether 2 non-touching loops are available. Please wait. Do you have 2 non-touching loops? No, we have 3 loops. All the 3 loops are touching each other. So we don't have 2 non-touching loops. So we are having only individual loops. So what about del? Del is equal to 1 minus sum of individual loop gain. What are those loop gain? 1 is minus BF, right? Plus CE plus G. 1 minus sum of individual loop gain plus sum of gain product of all possible combination of 2 non-touching loops. We don't have 2 non-touching loops, so we stop here itself. So that is equal to 1 plus B of F minus CE minus G. We found del, right? So K is equal to 1, right? So what is my transfer function? 1 by del summation of Pk del K, right? So and K is equal to 1. So K is equal to 1 means 1 by del P1 del 1 only we have to find. Del we know, P1 we know. What is del 1? Del 1 is given by, it's stuck here. So we have to find del 1. Del 1 is given by del 1 is equal to del for that part of the graph which is not touching kth forward path, right? So how to find? So we are having first forward path. For that we have to find del value, right? So what is that del value? For del 1 is equal to del for that. Del is equal to, we know, 1 minus sum of individual loop gain which is not touching the first forward path. But here you see in our diagram all the loops are touching the first forward path. So we don't have any loops touching the first forward path. So all the bracket terms will be 0. So del 1 is equal to 1 only, right? What is del 1? Del 1 is a del only, but for that which contains the loops which is not touching the first forward path, but all the loops are touching the first forward path. So we have del 1 is equal to 1. Now its transfer function is 1 by del we know. Del is given by 1 plus BF minus CE minus G into P1 del 1. Del 1 is 1, P1 is ABCD. So what is my answer? ABCD divided by 1 plus BF minus CE minus G. So 1 plus BF minus CD minus CE minus G. So option A is the right answer. That's all about this session. If you are having any doubt, please ask me in comment section. I will clarify all your doubts. Thank you.